All right, we are now venturing into section 7.5 in your textbook. That can be found if you want additional examples and whatnot on page 476. Okay, so 476 in your textbook. We are going to deal with the sum and difference angle formulas. Now, where they come from, it's pretty rad, but that's in your textbook. So if you want to look, feel free. I'm just going to give it to you guys straight out. So if I have two angles, and the angles we're going to be using are alpha and beta. Okay, so sum and difference, it's just that. If I have the cosine of alpha plus beta, its formula to calculate whatever that number may be is cosine of the first angle times cosine of the second angle minus the sine of the first angle times the sine of the second angle. Okay, that's for the sum. The difference, quite similar, is cosine of the first angle minus the second equal to the cosine of the first angle, cosine of the second, plus sine of the first angle, sine of the second. So check it out. Cosine, sum, is subtraction. Cosine, subtraction, is a sum. So the way that I remember that is that cosine changes the sign. Okay, so if you can remember that it's cosine first, cosine second, sine first, sine second, just remember, and those are angles, that the cosine formulas are going to change signs in the formula. Okay? For sine, it's kind of similar. So if we have sine of the first angle plus the second, that's going to be the sine of the first angle times the cosine of the second plus the cosine of the first angle times the sine of the second. Okay, that's for the sum. For the difference, we have the sine of alpha minus beta. And that's going to be the sine of alpha, so the first angle, times the cosine of the second, minus the cosine of the first angle times the sine of the second. Okay, so cosine changes, sine stays the same. Sine stays the same. Just little tricks to remember what those, sine, same. Just to remember what the operations are as we go from one to the next. Okay, tangent, sum and difference. Well, we know that tangent is sine over cosine, right? Okay, well, the sum and difference formula is this. If we have the tangent of alpha plus beta, so the sum, it's the tangent of alpha, so the first angle, plus the tangent of the second angle divided by 1 minus the product of tangent alpha, tangent beta. Okay, that's the sum. For the difference, we have tangent alpha minus beta. In the numerator, it's tangent of alpha minus the tangent of beta, and that's a really awful alpha, sorry, all over 1 minus the tangent, plus tangent alpha times tangent of beta. I'm really not digging that alpha. There we go. Okay, so like I mentioned earlier, tangent is sine over cosine. So same over change, sine over cosine. For the difference, right, same over change. Okay, so just little ways to remember. Oh gosh, sorry guys. But how the heck do we use it? Well, let's do it. So example number 1 says to find the exact value. Okay, this does not mean grab your calculator. This doesn't mean put it into photo math, ladies and gentlemen. This means find the exact value. Okay, so immediately in my head I'm thinking, well, shoot, I know 30 degrees. I know, oh fudge, there we go. I know 60 degrees and I know 45. And this is pi over 6, pi over 3, and pi over 4. Okay, so those are the degree and the radian measures that we know their exact values. Well, 7 pi over 12 is not one of them. So, gosh, okay. Sum and difference formulas. We know it's going to be cosine, and I know I'm going to have to add or subtract. And I'm going to try to add just because that'll come a little bit easier to me. So I could do pi over 12 and 6 pi over 12. 6 pi over 12 reduces to pi over 2, but I don't know pi over 12, okay? I could do 2 pi over 12 and 5 pi over 12, but we run into the problem with 5 pi over 12. We don't know what that is. Okay, let's see. We could do 3 pi over 12 plus 4 pi over 12. Well, that might work. Let's reduce. So we have the cosine of pi over 4 plus, hey, pi over 3. Awesome. Okay, so that works. So even though it was 7 pi over 12, we were able to find 2 radian measurements that added to that then reduced 2 radians that we actually knew their exact values, and that's what we need. So let's go ahead and plug this into our cosine sum formula. Okay, so we know that it's going to be cosine of the first angle, which is pi over 4, times cosine of the second angle, minus, because we change the sign, so minus sine of the first angle times sine of the second angle. All right. So then, well, cosine of pi over 4, it's in the first quadrant, and it is a positive rad 2 over 2 times cosine of pi over 3, still in the first quadrant, it's a positive 1/2, minus sine of pi over 4, rad 2 over 2, times, times sine of pi over 3, still in the first quadrant, which is rad 3 over 2. All right, keep going. Rad 2 over 4 minus rad 6 over 4, and then go ahead and combine the numerators. Because we have the same denominator, we just write it as rad 2 minus rad 6 all over 4, and we're done. That is the exact value. I can't combine the radicals because they don't have the same radican underneath. Okay. For B, it's in degrees. Yay! I know some of us prefer that. So 15, well, to add, you could do 10 and 5, but that doesn't fall into our 30, 60, 45. We could do a subtraction and difference, and I'm thinking that we should do the cosine of 45 minus 30, because that will give us 15 degrees. So now we're going to use the difference formula for cosine. So cosine of 45 times the cosine of 30 plus, because it changes, the sine of 45 plus the sine of 30. All right, so then we get rad 2 over 2 for the cosine of 45 times cosine of 30, we're in the first quadrant, is rad 3 over 2. And then we get plus rad 2 over 2 for the sine of 45 times 1/2, which is the sine of 30. We get the square root of 6 over 4, just multiplying across, plus the square root of 2 over 4. Because they have the same denominator, we can combine numerators into one fraction, and that's our exact value. Nice job. All right, for sine. Okay, sine of 19 pi over 12. We're going to have to play around again because we've got that pesky 12 as the denominator. But let's see. So we could do 10 pi over 12 plus 9 pi over 12. Let's think. Well, that reduces... I do think this will work. Hey, on the first try. Okay, so 10 pi over 12 reduces by 2. So you get 5 pi over 6, which we do know is in the second quadrant with a 30-degree reference angle, so that works. And then 9 pi over 12 divided by 3 gives us 3 pi over 4. Again, we're in the second quadrant, and it has a 45-degree reference angle. Rad. Okay. Let's use the sine sum formula. So we get the sine of the first angle, which is 5 pi over 6, times the cosine of the second angle, 3 pi over 4. Sine stays the same, so plus the cosine of the first angle, 5 pi over 6, times the sine of the second angle, 3 pi over 4. Okay, so we're in the second quadrant right here. So sine and its reciprocal are positive. 5 pi over 6 is going to be a positive 1/2. Cosine is negative, and that's going to be a negative rad 2 over 2. Plus cosine 5 pi over 6 is going to be a negative rad 3 over 2, because again, we're in that second quadrant, and sine of 3 pi over 4 is a positive rad 2 over 2. So when we multiply across, we get negative rad 2 over 4 minus square root of 6 over 4. So negative rad 2 minus rad 6 all over 4. Now, before we get to that last example, you might choose different combinations to perform for these sum and differences. So let's say for the one we just did, your answer comes out to be negative rad 6 minus rad 2 all over 4. Same thing, okay? If your answer for B is rad 2 plus rad 6 all over 4, same thing, all right? There are different combinations for sum. So if you do it a different way than I do in the homework, totally fine. We just need to make sure we have the same answer. Okay, so same numbers, same signs attached to them, and so forth. But ask me if you guys have questions. Okay, so tangent of 195, right away I'm thinking tangent of 135 degrees plus 60. Okay, so tangent is tangent of the first plus tangent of 60, because it's the same in the numerator, over 1 minus, because it changes, the product of tangent of the first angle times tangent of the second. Okay, tangent of 135. We're in the second quadrant, 45-degree reference angle. So sorry. So tangent is negative. Okay, so we have a negative 1 plus tangent of 60. First quadrant, it is the square root of 3 all over 1 minus negative 1 times rad 3. All right, so that means we have negative 1 plus the square root of 3 all over 1 plus the square root of 3. Just for fun, let's rationalize it. Yes, I want you to. So you multiply by the conjugate. The conjugate and the reason why. So the conjugate is the same binomial, opposite operation. Okay, so we're going to multiply the top and the bottom by 1 minus rad 3. The reason we do this is to get the radical out of the denominator. Okay, the conjugate will cancel out the middle term. For those of you that have heard me talk about it, we don't FOIL, we don't OI. Nope, we don't OI, we just FOIL. First and last. All right, but in the numerator, we have to FOIL it all out. Yeah, so we get negative 1, and then we get plus rad 3 minus 3, because rad 3 times rad 3. In the denominator, the first and the last. Okay, so combined like terms, we get negative 4 plus 2 rad 3. Don't forget with radicals, you add what's on the outside only if they are the same radicaned, and a negative 2 in the denominator. Well, you can reduce. Yep. So I'm going to pull out a negative 2 out of the numerator. That leaves me with 2 minus rad 3 all over negative 2. Those reduce. This problem is fantastic. And we're left with 2 minus rad 3. That's pretty freaking awesome. Yes! So ladies and gentlemen, sum and difference formulas, how you can use them to find exact values. Now, you can also work backwards. Find the exact value. Well, I say work backwards because I don't know the cosine of 40 without a calculator. And it says exact, so no. Calculators are off, like they're not even in the question. Put it away. So I'm going to look at my sum and difference formulas and I'm going to think, okay, which one has cosine in the front, sine in the back? And immediately I'm thinking, okay, it's going to be cosine. So this is some cosine formula of the first angle and the last angle. And then cosine changes, so it's plus. So truthfully, this should just be calculating the cosine of 120 degrees, which we know is in that second quadrant with a 60-degree reference angle. Cosine is negative, so it is a negative 1/2. Easy peasy. If we look at B, well, yes, it is definitely a tangent. Okay, so same is in the numerator because it's sine over cosine. So I know that this is going to be the tangent of the first angle minus the second, which means that it is the tangent of 30 degrees. Tangent of 30 in the first quadrant is positive, and it's going to be a positive rad 3 over 3. Yeah, those are kind of fun. They're different. Example 3 is a hoot because it involves a little bit of work. I know. Yay. Okay. So there's two different things. We have an alpha and we have a beta, and they're in two different quadrants. Okay, so I'm just gonna, I'll do it in gray. The first one is between pi over 2 and pi. So if I'm thinking 0, pi over 2, pi, 3 pi over 2, and so forth, that means that I'm in the second quadrant. And that means that I'm going to be drawn like this as a right triangle. My reference angle is at the origin. It tells us that sine is 3 over 5, so that's opposite over hypotenuse. You can use the Pythagorean theorem to find the missing side, or you can just know your triples, and this is 4, but it's negative because we're in the second quadrant, and that's the negative x-axis. Okay, so there's your alpha triangle. Now you need to find your beta triangle, and why? Because they give us alpha beta, but also because we're finding difference and sum of these angles. So we need to know where they come from. So this one's between, beta is between 3 pi over 2 and 2 pi. So that is in the fourth quadrant. So it would be drawn as such with beta at the origin. It tells us that sine of beta is negative 1 over rad 5. And I know that it's negative 1 because that's the negative y-axis and because the hypotenuse is never negative. If I were to use the Pythagorean theorem, it would be rad 5 squared equal to what we need squared plus negative 1 squared. So x squared is going to equal 5 minus 1, which is 4. So x is just 2. Okay? Okay. And that's positive. All right, let's do it. So for the first one, we have the sine of alpha minus beta. So sine of alpha minus beta, it's the sine of the first angle times the cosine of the second, same sign, so minus cosine of the first angle, sine of the second. I'm going to use my triangles. In the alpha triangle, the sine is 3/5. In the beta triangle, the cosine is 2 over rad 5. We can deal with the rad in the denominator in a second. Minus cosine of alpha is negative 4/5. And the sine of beta is negative 1 over rad 5. Okay, so before I multiply and combine anything, I'm going to go ahead and rationalize. So this is 2 rad 5 over 5 minus negative 4/5 times negative rad 5 over 5. Okay? All right, multiply across. So we get 6 rad 5 over 25 minus the negative cancel out. We get 4 rad 5 over 25. They have the same radicand. This is so exciting. So we get 2 rad 5 over 25. Nothing reduces. Ladies and gentlemen, this is the sum of alpha minus beta. The crowd goes wild. Totally ran out of space. So we'll do up here the cosine of alpha plus beta. Cosine of alpha plus beta is going to be, here we go, cosine of the first times cosine of the second. Sign changes. Sine of the first, sine of the second. If we look back at our triangles, the cosine of alpha is a negative 4/5. So we have negative 4/5 times the cosine of beta, which is 2 rad 5 over 5. I'm just going to go ahead and rationalize since we already did. Minus the sine of alpha, which is 3/5, times the sine of beta, which is a negative rad 5 over 5. Again, already rationalized. Multiply across, we get negative 8 rad 5 over 25 plus 3 rad 5 over 25. Keep going. So we get negative 5 rad 5 over 25, and we can reduce, so we must, which means we get negative rad 5 over 25. Final answer. Nicely done. Nicely done. Okay, it's a really ugly Roman numeral 3. So tangent. So we have tangent of alpha minus beta. So that is going to be, I'm running out of room. Tangent of the first angle, same. So minus tangent of the second all over 1 plus tan alpha, tan beta. Okay, so tangent of alpha, if we go back to the original triangle, it's opposite over adjacent, is a negative 3/4. minus tangent of beta, which is a negative 1/2, all over 1 plus negative 3/4 times a negative 1/2. Okay, keep going with me. So then we get negative 3/4 plus 2/4, because we need a common denominator, divided by 1 plus 3/8. So we get negative 1/4 in the numerator, divided by, this can be 8 over 8, which gives us 11/8. We get negative 1/4 times 8 over 11. These can reduce, and our final answer is negative 2 over 11. So cool. I think it's super fun. Come on, you know you do too. Don't lie to yourselves. Okay, so for B, we're going to do the same thing. We are going to find alpha. It tells us it's greater than negative pi over 2, but less than 0, which means we are in the fourth quadrant. Alpha is at the origin. Cosine is adjacent over hypotenuse. If you were to use the Pythagorean theorem, you would find that this is negative rad 3. Negative, sorry guys, because it's in the fourth quadrant. Okay, for beta, we're between 0 and pi over 2, so we're in the first quadrant. Beautiful triangle. Beta is at the origin. Sine is opposite over hypotenuse. And again, if you were to do the Pythagorean theorem, you would get 9 minus 1, which is 8, square root of 8, 2 rad 2. Everything's positive. Okay, so let's start. Number 1 is the difference formula for sine. So we get sine of alpha minus beta, which is sine of alpha, cosine of beta, same sign, so minus cosine alpha, sine beta. The sine of alpha for this, because we're not up at that example anymore. Okay, don't think about that one anymore. We're now down at these triangles. So the sine of alpha is a negative rad 3 over 2. The cosine of beta is 2 rad 2 over 3 minus cosine of alpha is 1/2, and then the sine of beta is 1/3. Just taking it from the triangles that we already drew from the given information. Okay, so then we get a negative 2 rad 6 over 6. Yes, you can multiply the radicals because they have the same index and we're multiplying. Minus 1 over 6. I'm not going to reduce because the denominators are the same right now, and if I reduce, then I can't combine. It would be counterproductive. So I'm just going to say negative 1 minus 2 rad 6 all over 6 is my final answer for that one. Nice. All right, for 2, we have the cosine sum formula. Hopefully this is getting you guys a little bit more familiar with the formulas that you just wrote down. So then we have the cosine of alpha, cosine beta, minus sine alpha, sine beta. Okay, cosine of alpha we know is 1/2. And then the cosine of beta we know is 2 rad 2 over 3. Minus sine of alpha is a negative rad 3 over 2. Sine of beta is 1/3. Okay, so multiplying across, we get 2 rad 2 over 6 plus rad 3 over 6. Here I cannot combine the radicals because I'm adding them. I'm not multiplying them like I was over here. Big difference. So you can just leave it as 2 rad 2 plus rad 3 all over 6. That's your final answer. Cool. And then last but not least, and there's only a couple of these in your homework. I was very cognizant of that. Chase told me the homework was too long, so I chose problems that were meaningful and not necessary. I mean, some are time consuming, but they are meaningful. Okay, here we go. So tangent difference formula. We have tangent of alpha, same sign up top, minus tangent of beta, all over 1 plus tan alpha tan beta. Okay, so tangent of alpha, if I go to the alpha triangle, it's negative rad 3 over 1, so negative rad 3. Tangent of beta is 1 over 2 rad 2. We'll leave that like that for now. So then we get 1 plus negative rad 3. Poop. We'll rationalize. Okay, so 1 over 2 rad 2. I'm going to multiply by rad 2 over rad 2. That gives us rad 2 over 4. Because this multiplied together is 2 times the other 2 is 4. Okay, so let's go ahead and change that. And then we'll put that down here also. Just going to make our life a little bit easier. Pardon me. So in the numerator, we can go ahead and say that it's negative rad 3 minus rad 2 over 4 all over 1 minus rad 6 over 4. Okay, so I'm going to do something a little funky here. I'm going to go ahead and get common denominators. So in the numerator, I'm going to have negative 4 rad 3 minus rad 2 all over 4 being divided by 4 minus rad 6 all over 4. And the reason is so that I can keep the first fraction the same and then multiply by the reciprocal. So then we are left with negative 4 rad 3 minus rad 2 all over 4 minus rad 6. Then we can multiply by the conjugate. Remember, same binomial but opposite operation to get rid of the radical in the denominator. Okay, if we FOIL in the numerator, we get negative 16 rad 3 minus 4 rad 18 minus 4 rad 2 minus rad 12 all over 16 minus 6. Whew, hot dog. Okay, so we have a few things to simplify, ladies and gents. We have negative 16 rad 3 minus the square root of 18 is 9 times 2 underneath, right? So 3 rad 2. So then we get minus 12 rad 2 minus 4 rad 2. Square root of 12 is 2 or 4 times 3 underneath, pardon me, so we get 2 rad 3 all over 10. Are we having fun yet? Oh, heck yeah, we are. Okay, so then, sorry guys, rad 3, right? We can go ahead and combine those, so we get negative 18 rad 3. And then we can combine these, minus 16 rad 2 all over 10. 18, 16, and 10 have 2 in common, so let's reduce for our final answer. We get negative 9 rad 3 minus 8 rad 2 all over 5, and that's it. That one's fantastic. Fantastic. Okay, we are at 27 minutes. I have 2 more examples to go through with you. I'm going to do it in a separate video, all right? So this is part 1.